Hi everyone. This week we are going to be discussing talk as a tool for learning. How can we have a productive discourse in the science classroom? So today's learning objectives include we're going to discuss the importance of discourse or conversation in the science classroom. We're going to describe strategies and tools to help your students engage in productive discourse. We're going to be discussing pre-thinking and the goals of different kinds of classroom conversations. We're going to discuss some cognitive demands of questions and tasks, and we're going to develop a repertoire of talk moves to serve the goals of the conversation. So, what is science discourse versus talking? We all can talk and we enjoy talking. Some of our students enjoy talking more than others. Sometimes we have issues with classroom management and talking. But discourse in science classrooms feels strange to students. We're asking students to do things like compare different science explanations, argue with evidence, critique a model, or unpack a claim. And that can feel very uncomfortable because that's not the type of talking our students are used to doing. Additionally, science has a lot of technical vocabulary and jargon, and many students don't feel sure using that vocabulary or jargon correctly. So we have to give students practice in scientific discourse and support it and scaffold it in a way so students feel comfortable talking science. So today and this week, we're going to talk a lot about how to encourage the talking of science, but also understanding what are the goals that we have when we do either whole class or small group discussions in our science courses. So why is fostering student discourse important? First off, it's a chance for your students to think, and thinking is required for higher level learning. Remember Bloom's? You have to think about things to get to analyzing and evaluating. It also means that taking a turn in a conversation requires your students to activate prior knowledge, which is something we always encourage in the science classroom for students to work with prior knowledge that they might have about a concept, a principle, or an experience they've had. Students also have to then organize possible responses that fit the flow of dialogue and nature of the audience, and verbalize their ideas while monitoring and adjusting in real time to what you are saying. And so it helps you as the teacher to identify any gaps in logic in real time. And that's really helpful too, because then you can kind of figure out where the lesson needs to go. So we're going to talk about 3 different types of discourse that we commonly see in the classroom. And I'm going to give you examples of each. So be patient because we're going to be sitting on the slide for a long time, but you really just need to close your eyes and listen. The first one is called initiation response evaluation. And unfortunately, this one is the one that we all do at least 90% of the time in our classrooms. And many times I, along with many other science educators in this country, observe during classroom observation. So we're going to talk about a lesson, and I'm going to discuss 3 different types of discourses around the exact same lesson. And so the way the teachers start a unit on the Earth, Moon, Sun system is they all do this by sharing a dramatic video of a total solar eclipse shot in India. It opens with a panorama of thousands of people gathered on the banks of a river on a late summer afternoon. They turn their attention to the sky and watch as the moon passes slowly in front of the sun. Within a few minutes, the sun disappears entirely behind the moon, and the crowd falls silent as the landscape momentarily becomes as dark as night. So this teacher has just finished the video and our students are eager to share their ideas. And so this is going to be an example of initiation response evaluation. Teacher. Okay, so we've just seen a solar eclipse. That's pretty cool, isn't it? Students, several together. Yeah. Teacher. This kind of event has to have three bodies in our solar system interacting. Can anyone tell me what they are? Michael, the sun and the moon is what you need. Then I don't know. Teacher, that's good, Michael, but there is a third body in our solar system involved. Does anyone else want to try? Sarai, the sun's light? Teacher, well, that is produced by the sun. But thank you for your idea. Anyone else? Katie, the earth? You got it. The earth is involved as well as the sun and the moon. Now, can anyone tell us what the moon is doing to the earth during a solar eclipse? Cooper? It's blocking it. Teacher, I think you're close. Anyone? Alyssa, is it like making clouds or a shadow? Teacher, exactly. The moon is casting a shadow on us here on Earth. Cooper, is that different like from a lunar eclipse? Teacher, yes, it's different because in the lunar eclipse, the Earth is getting between the sun and moon, and the Earth is casting a shadow on the moon. The teacher then transitions out of the whole class talk and into an activity. So what you heard was an example of initiation, response, evaluation. Initiation is the question by the teacher with a known answer and requires only recall of facts or a simple calculation. The response is usually the first person to raise their hand or be called upon, and the evaluation is a comment signaling to the students if the answering student is correct or not. So what's happening here is correct answers are valued over thinking. Now, imagine if English was your second language. This type of discourse, this initiation, response, evaluation, is going to always favor quick thinkers with access to science vocabulary. So if you have English as second language learners or students with IEPs that involve verbalization, they will never get to participate in this type of discourse, or very rarely. Also, the teacher is going to cherry pick correct answers from the students. And unfortunately, it is so common, this type of discourse, and I know we all do it, I do it, everyone does it, that it actually becomes the default pattern of talk in schools. So what I would like you now to hear is a different type of discourse. This is called a popcorn conversation. So this time, again, the students have just watched this video with this phenomenon where folks have watched this eclipse, and I want you to listen to the discourse between the teacher and students that shows popcorn conversation. So here it goes. Teacher, okay, I can tell you all want to talk about what is happening, but can everyone first take a few minutes to turn to a partner and discuss what you observed? Then partner conversation begins, and after 5 minutes, the teacher calls the students back. Who'd like to start? Jaden, we said the sun disappeared. Maria, no, the clouds were coming between the earth and the sun. I saw that. Teacher, I'll write your observations. You keep going, and writes on the whiteboard as the students talk. Carmen, it's the sun. It's the moon, we said. We saw it. It was coming closer to the earth, and when it gets close, we get the eclipse. It can happen once a month. Teacher, okay, good. Giovanni? Giovanni, the moon is putting a shadow on the sun. The earth and the sun are lined up, but doesn't happen very often. Teacher, thanks, Giovanni. That's an interesting theory. Anyone want to add? Helena, so what Carmen said, the moon has phases every month. The moon can have eclipses too? Giovanni, if it was clouds all the time, I think it is the moon getting right between the earth and the sun. Teacher, okay, these are all really fascinating ideas. Thanks to everyone for sharing. We're going to go find out the answer to these questions over the next few days. And then the teacher transitions to the activity. So what's different between this and the IRE? Well, first off, the teacher does not evaluate the contributions nor try to get students to say anything in particular. So in this case, the teacher is just letting free flow happen, and we're letting these students just pop ideas off. You do notice that the students' responses are longer. They're more like mini explanations, and the teacher acknowledges and records comments, but does not do anything with them. And this is where we fall flat. Ideas burst across the room and then fade away after getting recorded. So we're not really linking ideas or comparing or contrasting the ideas of these students. And this would be a beautiful space to do that. However, the teacher does give everyone an opportunity to share their ideas and record them on the board. The next one you're going to hear is a responsive orchestration of discourse. And what you'll notice is that this one is significantly longer. So in this case, this teacher finishes the video and asks students to record their observations silently for a few minutes. As they work, this teacher walks between the desks, occasionally jotting down what certain students write in their notebooks. Then the teacher gives them time to talk as partners for a few minutes before continuing. So here is an example of a responsive orchestration of discourse. Teacher: okay, we've had a chance to think. Can we share some observations? Callie: well, I saw the sun. It goes dark little by little, like... Teacher: can you say more about that? Callie: I saw the sun like it was taking a bite out of it. The sun was moving behind the moon really slow. Well, one of them was moving, but I was not sure which one. Teacher: does anyone want to add to what Callie has said about the sun and the moon were moving? Ava: the sun. The sun looked like how the moon looks when it has its phases, a half moon and quarter moon, like a circle is cut out of it. I don't know if the sun or the moon is moving, probably the moon because it's smaller. Darius: it was happening fast. It was getting blocked and went through phases in just a few minutes. So both of them might be moving past each other. Teacher: so we have a question about whether the sun was moving, the moon was moving, or maybe both, and then how fast. Okay. Lena: I saw that you had written something interesting that you observed. Can you share that? Lena: but it wasn't really about the eclipse. It was about something else. Teacher: but what you're observing and you note might give us a clue about what is happening. Are you sure you don't want to offer that? Lena: well, the people are waiting by the river. Teacher: that totally counts as an observation. Does that mean that if people are waiting for something to happen? Silence for 20 seconds. Teacher: let's turn and talk to a neighbor about the question. Does it mean anything if people had gathered by the river ahead of time? Then the students converse for 2 minutes. Teacher: okay, did any group have something they wanted to say about this? Marcus: we said if they were waiting, they knew what it was coming. Teacher: what do you mean they knew it was coming? Marcus: they knew it ahead of time. They were all dressed. It was kind of like a ceremony. They were all looking up at... Polly interrupts. Someone predicted it. I don't know, but it could have been on the news ahead of time. Otherwise, they would not go out there. It was something special. I don't know. Ephraim: I know my uncle saw a total eclipse in Turkey when he was a boy. They all got together in the town and watched it together. He's never seen one since. Teacher: did he tell you anything about how it happened? Ephraim: it was just like people cheered when it got dark and they took pictures and then it got light again, like nothing happened. Teacher to whole class: does anyone who has not had a chance to talk yet want to add any of your classmates' questions or ask them about their ideas? Brian: I have a question for Ephraim. Did the solar eclipse happen again for anybody you know? Ephraim: no, my uncle has the only story. Teacher: why do you say that? Lena: so it can't be the moon going in front of the sun. Why do you say that, Lena? Says the teacher. Lena: because the moon always goes around the earth. I know it goes around every month. So if it's the moon, then the solar eclipse would happen all the time. Teacher: so I'm hearing 3 puzzles that have all been brought up. The first is, does the moon have anything to do with the solar eclipse? The second is, how do people know it is going to happen? And the third is, why is a solar eclipse really rare occurrence? Let's write these up here and record the questions on the corner of the whiteboard. And we will spend the next few days figuring out how we can answer these. And then the teacher transitions to the activity. This is what's happening. They're not just theorizing what is happening, but explaining the why behind it. Why did it get dark? We saw so many small talk moves by this teacher that we're going to talk about later in this lecture. Like you heard the teacher say, Callie, can you say more to that? So the teacher's pressing Callie to tell us more. The teacher says things like, anyone want to comment on the thoughts or experiences of their peers? So again, we're conjuring that previous experience of our students. And then at the end of class, the teacher recaps the major themes as questions pursued throughout the lesson and records them on the whiteboard. So as each question gets answered, they can then address it again and the students can see it visually. Something we don't do especially well as teachers is we don't identify the goals for different types of conversations. We usually think, okay, I'm going to do a whole class conversation here, I'm going to do a small group here, but we don't think about what it is exactly we're trying to achieve with these conversations. So what I'd like you to do is to start to pre-think where you want to end up at the end of the conversation. And then that allows you to select the routines and tools for the discourse. So what is it that you want your students to get out of at the end of our conversation? For example, do you want students to develop a list of initial hypotheses after observing a particular phenomenon? Do you want them to critique an explanation? Do you want them to make sense of a particular activity? Once you identify that goal, then you can choose the particular type of discussion you want to have. So here are a couple of various ways that you can use discourse in your classroom. The first is activating and eliciting student ideas about a science phenomenon. The goal of this is to draw out students' beginning understandings of an event or process in the world. This usually happens at the beginning of a unit after your students watch a video, examine a photograph, or watch a demonstration or experiment, usually after they've observed whatever phenomenon you're going to use for that lesson. And the start of the discourse, we want everyone to participate. So the recommendation is that you use either small group or partner discussion. And you give very specific questions to start with, like, what do you see happening here? How do you think this happens? And then once you've done the small group or partner discussion, then you bring back the entire class to decide, what do we know about this phenomenon, why, and what are we unsure of? When you give those specific questions at the beginning to those small groups or partners, you're setting up the expectation of what you want your students to observe. You could also have key terms that you want students to use when describing what they've seen and have those also listed on the board. I think something that's really important is that you not only verbally give these questions, but also have them written out on the PowerPoint or on your whiteboard so that students can see them and think about them as well. Another way we can use discourse is to help students make sense of new observations, information, or data. So the goal of this is for students to recognize patterns in data or observations, critique the quality of the data, or propose why these patterns exist. Small groups and partner discussions are best for this versus whole class. And what I would recommend is that you circulate during these conversations and listen closely and ask questions like, what patterns do you see in this table or on this graph? Let's look at this part of the graph or the table so you can focus students in on specific parts that you want them to really observe and think about. You could ask them things like, what is going on at the system level? And then if your students are really catching on to understanding this observation or data, you can start asking them things like, well, what if we change something? How would that change the data? So if you changed a variable, like a temperature or an organism, what would happen to the data set that your students are working with? Another way we can use discourse is by connecting activities to big scientific ideas. So the goal of this is to apply what is learned during activities or reading to a phenomenon that students are trying to explain. This is basically how we teach science, right? We introduce a phenomenon and then we do a bunch of activities and lessons, hoping that those will elicit ideas and help them connect it back to that phenomenon. So we relate what they know so far to a puzzling science event. Whole class conversation, so peers can hear each other's ideas. Now, when you do these whole class conversations, you need to be very open to ideas and even listening to the off the wall ones. And if you're not getting a good whole class buy-in, then do the turn and talk for 2 minutes and then have partners share comments on their other partners' ideas. And we saw that with our last teacher conversation where the teacher wasn't getting much out of her students. And so what she did was she gave them a turn and talk moment to allow them to flesh out their ideas with each other. And then what you can do as a whole class is you can ask things like, can we all agree upon X? Where do we disagree? What do you need to learn more about to solve this problem? We see this a lot in our scripted curriculum, such as iHub, Amplify, and PhD Science. And it's useful because it really does help your students connect back to that main phenomenon that they're introduced to early on in the unit. We can also use discourse for pressing students for evidence-based explanations. And I think that this is something that students really need to practice because usually students are not asked to make evidence-based explanations. So this usually occurs in the middle of the unit and then again near the end. And the goal is to assist our students in using multiple forms of evidence gathered over several lessons to construct an updated explanation of the phenomenon. For example, we've completed several activities and assignments in this unit. Now it's time to use these together to revise our explanations or models for this puzzling phenomenon. So if you taught a specific science lesson with a phenomenon and you had your students write down, and I would say this is good for small group, and they should record the revision somewhere like a lab notebook or a science notebook. So at the beginning of the lesson, if you have your students write down what they think is happening and an explanation about it, and then you do a couple of days of activities, labs, or readings, then you can have them go back and reread what their initial thoughts were about that phenomenon and revise it. Now, those are all great, right? Like now you have some ideas of the types of goals that you may want to set and the types of discourse that you may want to use. But when you're using discourse, you need a toolkit, and you use these tools with one another to achieve a conversational goal. So these are specific ways to achieve those goals, and almost always you have to use one in hand with another. So the first one is probing. And I think you guys have seen me hear about Paige Keeley's probes a whole bunch. They're so terrific and you can use them in K through 12. But probing is a question or prompt that make public a student's observations, thinking, or past experiences. And in class, I'm going to talk a lot about how I use probes as a formative assessment to identify or evaluate my students' prior knowledge about a scientific concept or phenomenon. So you're not evaluating responses, but rather getting everyone's experiences and initial ideas into the conversational space. So for example, let's say you show a video of a singer breaking glass using only their voice. Then your probe would be things like, what did you notice happening here before, during, and after the glass broke? What did you think was going to happen? And what experiences have you had with really loud sounds or really high-pitched sounds? Now, these could be excellent exit tickets. These could be great bell ringers. This could just be a great formative assessment in the middle of the beginning of your unit where you can kind of elicit these ideas. And again, like I said, I'm going to talk a little bit more about this when we meet over in class. The next one is follow-ups. These are really important. If you follow up with a student, you're showing the student that you want to know more about their thinking. And you're not just being like, great, okay, next. Like that popcorn conversation we saw, that teacher didn't put value on any of those responses because they didn't evaluate any of them. But if they had followed up, then it helps your students, especially those students, when they give you one of those like off-the-wall answers. You can use a neutral or positive uplifting tone when asking them, like, where did that question come from? So like, why did they answer it that way? Or what was their idea that brought them to that answer? You want to be able to prepare to ask questions in pairs. So you want to do an initial probe and then a follow-up. So examples of follow-up questions can be, can you tell me more about that? Can you explain or describe it in a different way so maybe we can better understand? Or what do you mean by that? And all those follow-ups can really help you understand better what your students are trying to express. Another tool is pressing. There are going to be times when we need students to reason further about something than they have said. Don't allow your students shortcut responses, unsupported claims, or taglines. You know, right? Or do you get it? There are 5 pressing moves you can use as a teacher, and we're going to go over each one, but they include asking for examples, pressing for consistency with other ideas or information that have been shared, asking for evidence or justification, requesting the students fill out an explanation, asking how one could test a claim or hypothesis, and then asking what-if questions. So when pressing students, when you're asking for examples, you can ask things like, can you give an example of the idea you mentioned? Or can you think of a case where this might hold true? When you're asking students pressing for consistency with other ideas or information, maybe from what they've already collected in the unit, you can ask things like, does your claim fit with that data that you have? Or how is your explanation different from your peers? But is what you're saying consistent with? And then you could insert the concept or scientific principle here. You can also ask for evidence or justification. You can ask them, what makes you think that? How did you arrive at that conclusion? What evidence do you have? How does that idea support your claim? And then you can always request that students fill out an explanation. It sounds like you have an ending, but what happens before that that leads up to this? So if students know what happens at the end of the observation, but not necessarily what that means, you can start to press them to figure that out. And then my favorite is always asking how one could test a claim or hypothesis. So you can say, well, that's a really interesting idea. Is there a way we could test that or see if it's true? And what resources might you need to do that? So you're really getting them to start to think like a scientist. Here's one that I'm terrible at, and it takes a lot of practice. And sometimes it even takes you having to teach the unit once and then figure out where you need to place that wait time because you just don't know until after you've taught it. And that's using wait time. So during whole class discussions, students need time to think. We always anticipate what the answer should be because we know the answers, but your students need to get there. So wait time makes conversations more equitable because your English as second language learners, your students who may have accommodations, they have time to think and put their ideas together before verbalizing it. So get used to silence. It's okay to hear silence every once in a while in your classroom, and try to extend wait times to 15 to 20 seconds. If you're having a really difficult time with this, I highly recommend using timers on your smartboard. All right, guys, I'm going to give you 1 minute to pair up with your partners and think about this or jot down your ideas and just set a timer. And then it keeps you on track, but it also gives your students some wait time. Wait time results in a greater percentage of students responding and longer, more thoughtful responses. So if you're really trying to get students to a particular point in the lesson, this is the way to do it. You can also open up crosstalk, and this is to get student commentary from each other in a civil manner. And I think this is such a terrific soft skill that students need to learn anyways, particularly in secondary science courses. So you can get students to talk to each other and then have them recap what their peers have said. So you can say things like, can you rephrase what Marie said in your own words and check with her to see that that's what she meant? Or can you tell Jordan whether you agree or disagree with this statement, why or why not? Or does anyone want to respond to that idea? Or can you compare your ideas with your partners? That's giving your students the tools to know how to agree or disagree with each other and how to have a civilized discussion about their agreements or disagreements, as well as presenting it to the whole class. Another tool is revoicing. I'm a big fan of revoicing. That's when the teacher listens to a student response, paraphrases it, and rebroadcasts it to the entire class. Now, when you are revoicing, you really need to understand the culture of your students and use this with caution. You never want a student to feel like you are overriding their ideas with your own or you're taking their ideas. So you really need to value the student and hold them up when you are paraphrasing it. And you need to ensure that you are paraphrasing it correctly. So you have to follow up with the student and make sure that they are in agreement with how you paraphrased it or have them paraphrase it in a different way. But this can be a very powerful way to connect everyday language to academic language, and it's used to mark a segment of a student's idea as important. Another tool is focusing. Sometimes students get really overwhelmed with a phenomenon, an assignment, or a task at hand. I mean, imagine a student who's already overwhelmed with math, and then you give them this massive data table with all these numbers and expect them to do calculations. Your students might get overwhelmed and shut down. What we want to do is prevent your students from shutting down. So focusing is drawing attention to smaller parts or smaller spaces. I always talk about if you're going to eat an elephant, how do you do that? We have to do it one bite at a time. The same is true for overwhelming parts of the units. So this can happen both at whole class and small group conversations, but you can ask questions about one part of the phenomenon or story. You could have them focus on a very specific activity in the unit. Also, this is a great point where you can break down data tables and graphs. So you can ask them things, well, what does this axis mean? What does this axis mean? What does this column mean? Why am I asking you to do this calculation? Things like that can really focus students on the task at hand besides getting completely overwhelmed and shutting down on you. Here's one I think we all need to practice as well, and that's putting an idea on hold. So in the excitement of the discussion, sometimes students make off-topic statements that would be better addressed later. So how do we politely acknowledge the student's idea or statement, but mark it something that won't be explored right now? Well, some teachers will devote space on the board or wall for these specific comments or ideas to show that they have value even if they don't fit in the moment of time. A lot of times you hear teachers using the term parking lot. Let's put that idea in the parking lot, and they'll use Jamboard or Google Docs to do that as well. Things you can say are like, I like that thinking, but let's hold off on that until later in the unit. Or this is a great point. Let's write this down because we'll be addressing it in the next few days. And then there might be some completely off the wall ideas or statements, but still things that you may want to address and say, you know, at the end of this unit, if we have some time, I definitely want to explore that with you. So again, you're valuing your students' ideas and showing the curiosity behind it. So this is coming from the textbook Ambitious Science Teaching. It's a terrific book, and I will do my best to share these chapters with you. But these are talk moves and ways to use combinations of them to accomplish the goals of the conversation. So here you can see the various goals and then the tools that you can use to get to those goals. And it's a really nice way for you to start to think, if I'm going to do a whole class or small group discussion, what is it that I'm trying to achieve? And then what tools make the most sense to achieve that? And for my teachers that have to currently teach online, either virtually, synchronously, or asynchronously, you can use things like chat and Nearpod voting and different probes in different ways and use educational technology to still drum up this discourse, even if it is not necessarily your students having real-time face-to-face conversations. Thank you all and have a great week.